Okay, today we are going to discuss about the most important topic of machine learning, which is confusion matrix. Today we will go through the in-depth intuition of this topic. So, to understand any topic properly, we should divide this topic into three parts. That is what, why, and how. Because what is that part, how it's work, and why we are learning this. So, confusion matrix is very important, but before going dive deep into the confusion matrix, we should understand some background of confusion matrix. So before going to confusion matrix directly, we should understand what is machine learning, why, where is the place of confusion matrix in machine learning. So we all know artificial intelligence, which is a branch of computer science, whereas machine learning is a branch of artificial intelligence. In machine learning, there are three types of algorithms are there, like regression algorithm, classification algorithm, and reinforcement learning. So we should understand this topic very wisely, but this is very vast topic. The most important part is supervised learning, unsupervised learning, and reinforcement learning. Whereas we should only focus on this video on supervised learning. In supervised learning, there are two types of algorithms are there, that is regression and classification. If you talk about regression, the regression algorithm predicts the continuous values like from any numerical number, and if you talk about classification algorithm, it predicts the classes like either yes or no, either positive or negative. So if you talk about regression and classification, so confusion matrix is the evaluation criteria of classification algorithm. Means evaluation criteria means we have to check how well our model built for this algorithm, for this data. So to check how well the model built on the historical data, the given data, we use confusion matrix. So confusion matrix is nothing but the evaluation matrix for classification algorithm. So now we have covered the first why. First what? So we have covered this, what is classification algorithm. So why we are doing this? Okay, we all know the type of data. The raw data we get for building a model is not in a pure form. It's a real world data. So it's not a proper data. It's have sometimes a biased data, sometimes imbalanced data. So in that case, when we have to predict the result may get biased into some class, and it's not good for our final model. So this is the confusion matrix of 2 by 2. Means we have predicted value and actual value. So what is predicted and what is actual? Again, these are new terms for us. So predicted values are the values predicted by the algorithm or model, whereas actual values are the actual values from that data. So to go or to simplify this, we again use some other definitions of two topics, that is training data and testing data. So we divide our data into two parts, that is training data and testing data. We use the training data to train the model, to the model learn the pattern from the training data, and then we use the testing data to check whether how well our model fit that data. So the predicted value we get when we fit the testing data to the model, whereas the actual values are the real testing values present in that data. Okay, let's simplify again. So here we have 0, here we have 1, here we have 0, here we have 1. For predicted class, we have positive and negative, or can say 1 or 0. Again, for actual class, we have 1 or 0, that is positive or negative. So again, there are 4 terms are here: true negative, true positive, false positive, and false positive. Those who are very beginner in that case, its terms are very confusing at first, but after this video, there will be no confusion in that case. So what is true negative and what is true positive? These are very simple terms we have to check. True negative stands for the negative class predicted by the model, and actually the class is also really negative. Means the class is negative actually, and the model also predicted as negative. That's what we call true negative. Whereas true positive is also same. This class is positive actually, and the model also tells that it's a positive class. These are very simple terms. There is no confusion in that case. But if you talk about these two classes, that is false positive and false negative, these terms are very important. False positive is a term predicted by a model that it's positive, but it's not positive actually. And this false negative is the term predicted by model that it's negative, but it's not negative actually. Okay, let's dive deep into that. Okay, false positive are the term predicted positive by model, but it's actually not positive. So we can take it an example. Suppose you are crack the interviews on any company, you have completed our HR discussion and everything, and HR told you on that he's going to send you an offer letter. So he sends you an offer letter, and you are using any some ABC type of email app, but your email app consider this offer letter as a spam and put this offer letter in a spam folder, and mostly no one open a spam folder in real life. So your offer letter is not the spam, but the model which is working back into that email app is consider this offer letter as a spam and put it in a spam folder. So what happened in that case? The model consider it as a spam, means consider it as positive, but it's not actually positive. But what will be the result? You will never get your offer letter, you will never check your offer letter, and maybe you will lose the opportunity to join that company if you never see the spam folder, and if the HR may not call you. So in that case, the false positive is nothing but the wrong result predicted by the model. And on the other hand, we have false negative. It's also important to know that model tells that it's negative, but it's not negative. Let's again consider this with example. Suppose one person who is going to hospital, and the hospital have again one machine learning model which predict the disease on the basis of past history, or I can say past medical history of the patient. The patient give his historical data to the model. The doctor fill that data, and the model predict that the person didn't have any disease. The person is happy. He says he doesn't have any disease, and he go to the home. But actually he has the disease. But the model predicted it as no disease. Means it predicted negative, but it's wrong negative. It's false negative. So the patient, what happened in that case? The patient may get serious in future, or anything else may happen. So the actual result are positive. The patient have the disease, but the model predicted as negative. So that's the term we called it as false negative. So these two terms are very harmful for our model, because it may create a major damage in the future with the help of this model. So we have to talk about this term we have to reduce those terms in order to increase the efficiency of model. So after learning this term, we have clear the second why we are building this, because these terms are dangerous for the model. These terms are harmful. So we calculate those terms, and we check the percentage of those terms, how many amount of these terms are present, like whether it is false positive or false negative. So we will go to our next question. This is how it's work. Okay, so we know when we feed data to the model, and with the help of one command from the sklearn scikit-learn library, we calculate our confusion matrix. So when we talk about confusion matrix, we have two terms here, which is false positive and false negative. We do not have any we don't have to take account into true negative and true positive, because these are correctly predicted data. But we have to focus on false positive and false negative. So if we talk about false positive, we consider false positive as type 1 error in machine learning. So if we say these two terms we have to reduce, but these two terms are basically related to domains. Like if we talk about medical domain, in medical domain, as we discussed earlier, false negative is very important, and it's very important to reduce the false negative term. Whereas if we talk about other example, like the email spam or anything, here false positive is very important to reduce. So there are some methods are there, like another term called threshold. Threshold is a very important number in the classification algorithm. We can reduce the threshold or increase the threshold in order to reduce the false positive and false negative. So this is how the importance of confusion matrix is there. It's very it looks like very simple, but it's very important and very related to real world data, real world problems. When we are using machine learning to solve the real world examples or real world business problems, in that case a single wrong result may cause the loss of various amount. So in that case, it's very important to talk about this and to reduce these terms. And basically, this is all about confusion matrix. So okay, we will revise everything in that case. So confusion matrix is an evaluation matrix for classification algorithm. When we have when we have data, we divide this data into two parts, that is training data and testing data. We provide the training data to the model so that the model can get learn on that. After learning the model, we get our confusion matrix with the help of scikit-learn library. There is the command for us confusion matrix. After getting the data, we get four values. These are true, negative, true, positive. True, negative are the negative values are actually negative and